I welcome you all for the joining process part 2 lecture. I am Dr. M.S. Elisha Vallavi, Assistant Professor in Mechanical Engineering, Government College of Technology, Coimbatore. Today we are going to discuss about the previous year GATE question and answers. First question is, two pipes of inner diameter 100 mm and outer diameter 110 mm each are joined by flash butt welding using 30-watt power supply. At the inference, 1 mm of material melt from each pipe, which has a resistance of 42.4 watt. If the unit melt energy is 64.4, then time required for welding is, okay, this is what they given. So here inner diameter and the outer diameter given, and it is by means of flash butt welding process, and power supply given, and the thickness 1 mm of material melts from each side. So each side 1 mm. So totally 2 mm, that we have to keep it in mind. Then resistance they give, and energy also given in the question. Now let's see how to solve this question. Given inner diameter 100 mm, outer diameter 110 mm. It is by means of flash butt weld, and voltage is 30 or resistance 42.4, energy 64.4 this mega, so 10 to the 6 joule per meter cube. So from that we want to know the time required. This is what the question given. So each pipe melts 1 mm of material, so that total thickness of material melt is 2 mm. Okay. So here at the interference 1 mm of material melts from each pipe. Okay, 1 mm of material melts from each pipe. So each side 1 mm. So that we have to consider here. Each pipe melts 1 mm of material. So totally 2 pipes. Thickness of material melt, that is equal to T equal to 3 into 1 equal to 2 mm, which is equal to 2 into 10 power minus 3 meter. This T is thickness. Otherwise we will keep it as capital P. Okay, to avoid confusion. So we have the equation Q equal to area into thickness into energy. That is area. Area is 5/4. Inner outer diameter is given. So outer diameter minus inner diameter, that whole square. into thickness, we are taking as capital T, into energy. Now while substituting, (64.4 into 10^6). So from that we are getting 212.32 joule. Now we want to know the time required for welding. That is what our aim, to find the time required for welding. Heat generator, that is Q. We know the formula, I square RT. Here the T is the time. We know that B equal to IR. So in question they give the V and R. So we are converting in terms of I into R. In question they gave the V and I. So we are converting I as in terms of V and R. So from this I can written as I equal to V by R. That we have to substitute here. V squared by R squared into R into T. So V squared by R into T. So from the question, V is 30 square or 42.2. So T we have to find out. Q we found from the equation, previous equation, that is 212.32 joule. 212.32, and that we can find the T. So finally we are getting 10 seconds. So this is what the answer. So answer is D. Next question is, which one among the following welding process use non-consumable electrode? So non-consumable electrode is this tungsten arc welding only, because melting point is high. We have two types of electrode, consumable and non-consumable electrode. Tungsten arc welding comes under non-consumable electrode. So gas tungsten arc welding is also called as tungsten inert gas welding. TIG. The arc is maintained between the workpiece and tungsten electrode by an inert gas. The electrode is non-consumable since its melting point is about 3400 degrees Celsius. That's why it is the non-consumable electrode. So option is C. Next, we have another problem. In DC arc welding operation, the voltage arc length characteristics was obtained as V arc equal to 20 plus 5L, where the arc length L was varied between 5 mm and 7 mm. Here V arc denotes the arc voltage in volts. The arc current was varied from 4000 amps to 5000 amps. Assuming linear power source characteristics, the open circuit voltage and short circuit current for the welding operation are. So now we have to find out the open circuit and short circuit current. Okay. First we will write the given. minus V equal to 20 plus pi L V aught. Length varies from 5 to 7 mm and I have just 400 to 100 amps. We know that power source character V by OCV plus I by SCC, which is equal to 1. In that OCV, which is equal to open circuit voltage SCC, which is equal to short circuit current. So we know that I equal to current, V equal to voltage. Now from voltage or length character, V aught equal to 20 plus 5L. So here L1 equal to 5 mm, L2 equal to 7 mm. So while substituting these two lengths in this equation, V1 will be 20 plus 25, V2 will be 35, then this is 55, then corresponding I. Okay. So now we will take this as equation 1. So substitute above values in equation 1. So V1 equal to 45, I1 equal to 500, V2 55, I2 400. That we have to substitute in equation 1. So after substitution, we are getting 45 divided by OCV plus 500 divided by SCC, which is equal to 1. In same manner, 55 divided by OCV plus SCC, which is equal to 1. This is equation 3. So we are getting two equations. Solve 213. So now we will equate 213. Minus 55 divided by HCV, which is equal to 400 minus 500 SCC. So minus 10 minus 100 divided by SCC. So from that we can get SCC equal to 10 OCV. So take it as fourth one. Substitute 4 in equation 2. So 45 divided by OCB plus 500 divided by SCC. In spite of SCC, we have to submit. Then OCB, which is equal to 1. While solving this is oh, this is 10. This is not 100. This is 10. So from that we can get OCB equal to 95 volts, SCC equal to 950 amps. This is what the answer. So we are using this power source character. By using the given, we are making two equations and we are equating those two equations to get the required answer. So here option is C, 95, 950. Question: match the correct pair. Friction welding, gas metal arc welding, tungsten inert gas welding, electroslag welding. This side non-consumable electrode, joining of thick plates, consumable electrode wire, joining of cylindrical dissimilar metal. Okay, so previously we saw about the tungsten inert gas welding. It is used for non-consumable electrode. So it is for R1. Then gas metal arc welding is consumable. Then friction welding is for joining cylindrical dissimilar metals. And electroslag is for joining thick plates. So option is A. Next question is, in solid state welding, the contamination layers between the surface to be welded are removed by alcohol, plastic deformation, water jet, sandblasting. Option is B, because plastic deformation is used to remove contamination layers between the surface to be welded in solid state welding. Next is a problem for spot welding of two steel sheet, each of 3 mm thickness. Welding current of 10,000 amps is applied for 0.2 seconds. The heat dissipated to the base metal is 1000 joule, assuming that the heat required for melting 1 mm cube volume of steel is 20 joule. And interfacial contact resistance between the sheet is 0.0002 watt. The volume of weld nugget is that we have to find out. So it is a spot welding process. We have two sheets. Plate. Then this is spot weld. Thickness 3 mm. We have two sides. So each thickness is 2 mm. Current which is equal to 10,000 amps. Then time 0.2 second. Heat dissipated is equal to 1000 joule. Then resistance 0.002. So now you can calculate the heat generated. Q equal to I square RT. So I is given 10,000 square R 2 into time is 0.2. So from that we are getting 4000 joule. So this is heat generated. So in the question they gave the heat dissipated to the base metal is 1000 joule. Okay. So that also we have to consider. Heat dissipated to base metal is 1000 joule. So heat required form to neglect is heat required to form nugget is, which is equal to total heat generated is 4000 joule and 1000 is for base metal. So we're getting 3000. This is heat total per nugget. So 2 joule heat forms 1 cube of nugget. We have totally 3000 joule. So that forms how much water? Forms how much? Okay, that we have to identify. So 3000 divided by 200. Sorry, 20 into 1. 150 mm cube volume. Next question is, within the heat affected zones in a fusion welding process, the work material undergoes microstructural changes but does not melt. Neither melting nor microstructural changes, both melting and microstructural changes after solidification. Melting and retains the original microstructure after solidification. The answer is A, that is microstructural changes but does not melt. The heat affected zone is the area of base metal which is not melted and has its microstructural and properties altered in fusion welding. The extent and magnitude of property change depends primarily on the base material, the weld filler metal, amount and concentration heat input by fusion welding process. So answer is A. Next question is, the major difficulty during welding of aluminum is due to its high tendency of oxidation, high thermal conductivity, low melting point, low density. Aluminum has high density of oxidation. So during welding, it is converted into aluminum oxide, and this aluminum oxide has very high melting point. It will not melt and welding cannot be performed easily. So option A is the right answer. High tendency of oxidation makes the difficulty of aluminum during welding process. Two plates each of 6 mm thickness are to be butt welded. Consider the following process and select the correct sequence in increasing order of size of the heat affected zone. Arc welding, MIG welding, laser beam welding, submerged arc welding. Laser beam welding usually highly focused beam for welding. Hence, heat affected zone will be less when compared to all other types of welding. In submerged arc welding, weld pool is completely covered by flux. Hence, in this welding also, heat affected zone is less but more than TIG and MIG since flux spread over more area. So, we are continuously pouring the flux. Below that, welding will be carried out. In metal gas welding, also will be using inert gas to protect the welding zone from atmospheric contamination since it uses electrode with inert gas for shielding. Heat affected zone is less than the submerged arc welding. In arc welding, we do not use any protection to weld pool. So, from this, we have to select the B. First one is laser beam welding, MIG, submerged arc welding. This is what the sequence. Which of the following joining process or autogenesis? Diffusion welding, electroslag welding, tungsten inert gas welding, friction welding. In autogenesis welding, no filler material is used and join takes place in solid state only. So this is the classification of autogenesis welding process. So solid state, we have four subdivisions: cold welding, friction welding, diffusion welding, hot forge welding. In cold welding, we have pressure welding, ultrasonic welding, explosive weldings are there. So friction welding and diffusion welding are the answer for this. So answer is A. Next question is, in a linear arc welding process, the heat input per unit length is inversely proportional to. So we have four options: welding current, welding voltage, welding speed, duty cycle of the power source. So welding current, so we know that Q equal to I square RT. So welding current increases as the heat input increases because the heat input is directly proportional to the welding current, that is Q equal to I square RT. So heat input per unit length equal to current square. Welding voltage, so welding voltage increases as the heat input increases because heat input is V square by R. So this can be written as V square by RT I equal to V by R. So heat input per unit length is directly proportional to the voltage square. It is directly proportional both the case. Then welding speed increases as the welding electrode spend less time to release the heat. When speed increases, heat input per unit length decreases. So welding heat input is indirectly proportional to the welding speed. Duty cycle, heat input is directly proportional to the duty cycle. So three cases are directly proportional. One is the indirectly proportional. So that is the welding speed. So this is what the answer here. Next one is problem. A DC welding power source has a linear voltage current characteristics with open circuit voltage of 80 volt and short circuit current of 300 amps. For maximum arc power, the current should be set as in amps. We have to calculate the relationship between open circuit voltage and short circuit current is given by this for maximum power. So we take it as dP divided by OCD plus IP divided by SCC, which is equal to 1. So multiply equation 1 with current. So VI divided by OCD plus IP square divided by SCC, which is equal to 1. So we know that P equal to V into I. So this can be written as P divided by OCD plus IP square divided by SCC. Here also it will become 80 into IP minus IP square by 300 is equal to IP. We have to substitute it. So in spite of this, to maximize the power, we have two conditions: EP by AP equal to 0 and V square P by V square is less than 0. From this equation, so that is minus IP square divided by 300. So dP by dAP that we have to differentiate is 80 into 1 minus 2 IP divided by 300. So that we have to equal to 0. So from this we can get IP as 150 amps dP by dAP square, which is equal to 80 into 2 divided by 300, that is equal to 0.33, which is less than 0. So from that maximum power, the current be set as 150 amps. Okay, the next question is one problem. In TIG welding process, the arc current and arc voltage were 50 amps and 60 watts respectively, wherein the welding speed was 150 mm per minute. In another process, TIG welding is carried out at a welding speed of 120 mm per minute at the same arc voltage and heat input to the material, so that welding quality remains the same. The welding current in amps for this purpose is V1 equal to 50 volts, I equal to 50 amps, S1 equal to 150 mm per minute. In another process, the speed is 120 mm per minute and arc voltage and heat input to the material is same. So voltage is same. For the second case also 2 volt. So we know that total heat input is VIT. So T is directly proportional to the inversely welding speed. Yes. So this can be written as VI divided by S1 is equal to V2 I2 divided by S2. So V is same for both the case. So we will cancel it. Both are 60 only. So that will be cancelled. Now we want to know the welding current of the second process. So I2 equal to I1 S2 divided by I1 S2 divided by S1. Now we will substitute 3 into 120 divided by 150. So we will get 40 amps. That's the two. Next one is a gas tungsten arc welding operation is performed using a current of 250 amps and the arc voltage 20 volt at a welding speed of 5 mm per second. Assume that the arc efficiency is 70%. The net heat input per unit length of weld will be dash in terms of kilojoule. Okay, so here given equal to 250 amps, voltage is 20 volts. So speed 5 mm per second. Then efficiency arc efficiency is 70%. From that we want to know the heat input per unit length. First we have to calculate the power given to the welding operation, that is P equal to V into I. V is 20, I is 250. So we are getting 5000 watts. So net heat input is 70% of power. So this will be 3500 joule per second. Net heat input per unit length, which is equal to net heat input divided by welding speed, which is equal to net heat input is 3500 divided by speed, which is given in the question itself, 700 joule per mm. So in the question they are asking in terms of kilojoule. So this is 0.7 kilojoule per mm. 0.7 kilojoule per mm is the right answer. The next question is, which one of the following weld method provides the high heat flux? Oxyacetylene gas welding, tungsten inert gas welding, plasma welding, laser beam welding. So we have a different welding process. Heat density and temperature is given here. So gas welding 10 power 2 to 10 power 3. Temperature varies from 2500 to 3500. Sheet metal arc welding 10 power 4. Then temperature is greater than 6000. Gas metal arc welding 10 power 5. Temperature is 8000 to 10,000. Plasma arc welding density is 10 power 6. Temperature 15,000 to 13,000. Electron beam welding 10 power 7 to 10 power 8 watt per centimeter square. Temperature varies from 20,000 to 30,000. Laser beam welding 10 power 9. Temperature is greater than 30,000 degrees Celsius. So from this, the answer is D. Resistance welding. Heat is generated due to the resistance between electrode and workpiece as per it is between touching plates. Two dissimilar metals being in contact, interatomic force. So answer is B, as per is between touching plates. In arc welding, the arc length should be equal to 4.5 times of the rod diameter, 3.5 times of the rod diameter, 1.5 times the rod diameter, then simply rod diameter. The stable arc required for high quality welding can be achieved by when arc length equal to 0.6 to 0.8 of the electrode diameter. As per this, the right answer is D. Next question is, the welding process which uses a blanket of fusible granular flux. Gas metal arc welding, submerged arc welding, gas tungsten arc welding, flux coated arc welding. In serve-merged arc welding uses the blanket for fusible granular flux. So far we discussed about the various gate questions from the previous years. So this is the reference book. Happy learning. Thank you.